In this video, we will learn about the foundational network programmability concept. First, let me to explain about the command line interface or CLI. There are many different ways to connect to and manage a network. The most commonly used method for the past 30 years has been by using the command line interface or CLI. However, like almost everything else, the CLI has pros and cons. Perhaps one of the most glaring and biggest flaws with using CLI to manage a network is misconfiguration. Businesses often have frequent change in their network environment, and some of those changes can be extremely complex. When businesses have increased complexity in their network, the cost of something failing can be very high due to the increased time it takes to troubleshoot the issue in a complex network. Failure in a network, however, doesn't necessarily mean software or a hardware component is to blame. A majority of network outages are caused by human beings. Many outages occur because of misconfiguration due to lack of network understanding. While not all outages or failures can be avoided, there are tools that can assist in reducing the number of outages that are caused by human error due to misconfiguration in the, for example, CLI. This table shows a brief list of common pros and cons associated with using the CLI. Let me to review them. About the, for example, advantage or pros, let me to say that the CLI is well known and documented. Also, it's commonly used method, and also commands can be scripted, and also syntax help available on each command. And finally, connection to CLI can be encrypted with using SSH. Okay. About the cons, difficult to scale, large number of commands, must know iOS command syntax. Executing commands can be slow, not intuitive, can execute only one command at a time. And CLI and commands can change between software versions and platforms. And finally, using the CLI can pose a security threat if using telnet, means if we use plain text method. Of course, there are programmatic ways of accomplishing the same configuration that are possible with the CLI. Let me to explain about some of them. First, I'm going to review the application programming interface concept and also the abbreviation of this that we call it API. Another very popular method of communicating with and configuring a network is through the use of application programming interface or APIs. APIs are mechanisms used to communicate with application and other software. They are also used to communicate with various components of the network through software. It is possible to use APIs to configure or monitor a specific component of a network. There are multiple different types of APIs. However, the focus of this video is on two of the most common APIs, the Northbound and Southbound APIs. The following part of this video explain the differences between the two through the lens of network automation. Okay, in this figure, as you can see, we can see the basic operation of Northbound and Southbound API. As you can see, for example, in one controller, we have Northbound API. With Northbound API, we can communicate with the controller with some applications, and also you know that controller with Southbound API can connect to the fabric, okay, or to the data plane, and it means that we can send our orders, our configuration, our monitoring requests to the controller with the Northbound API, and controller can send them with Southbound API to the data plane, to the, for example, fabric. About the Northbound API, Northbound APIs are often used to communicate from a network controller to its management software. For example, Cisco DNA Center has a software graphical user interface GUI that is used to manage the network controller. Typically, when a network operator logs into a controller to manage the network, the information that is being passed from the management software is leveraging a Northbound REST-based APIs. Best practices suggest that the traffic should be encrypted using TLS between the software and the, for example, controller. Most type of APIs have the ability to use encryption to secure the data in flight, and REST APIs, you know, that are the APIs that we can use them for communicating between two different devices, okay, over a network with, for example, HTTP, and it means that we have REST client, we have REST server. About the Southbound API, you know that if a network operator makes a change to a switch configuration in the management software of the controller, those changes are then pushed down to the individual devices by using a Southbound API. These devices can be routers, switches, or even wireless access points, and APIs interact with the component of a network through the use of a programmatic interface. About the representational state transfer or REST APIs, you know that an API that uses REST is often referred to as a RESTful API. RESTful APIs use HTTP methods to gather and manipulate data. Because there is a defined structure for how HTTP works, it offers a consistent way to interact with APIs from multiple vendors. REST uses different HTTP functions to interact with the data. This table, the top table, can show us or list some of the most common HTTP functions and their associated use cases. Let me to review them. For example, about the HTTP function of GET, the action is request data from a destination. For example, we can use it for viewing a website. The HTTP function of POST, submit data to a specific destination. It means that we can use it for submitting login credential. About the PUT HTTP function, the action is replacing data in a specific destination. We can updating an NTP server. About the patch HTTP function, the action is appending data to a specific destination, adding an NTP server. And about the HTTP delete action, it can remove data from a specific destination. It means that, for example, we can use it for removing an NTP server. HTTP functions are similar to the functions that most application or database use to store or alter data, whether the data is stored in a database or within the application. These functions are called CRUD functions. CRUD is an acronym that stands for create, read, update, and delete. I explained it completely in the previous video. Here we are reviewing the REST APIs. For example, in a SQL database, the CRUD function are used to interact with or manipulate the data stored in the database. The bottom table here lists the CRUD function and their associated actions and use cases. First, create. Insert data in a database or application. Use case, updating a customer's home address in a database. About the read action, retrieves data from a database or application, pulling data and pulling up a customer's home address from a database. About the update, modifies or replaces data in a database or application. About the use case, changing a street address stored in a database. And finally, delete action. It removes data from a database or application. Removing a customer from a database is the use cases of the delete of the, for example, CRUD. You know that we can use HTTP because it can provide us all of the CRUD functions. Okay, and you know that because of that, for RESTful APIs we use HTTP. For with the verb of HTTP we can do all of the functions that we need about the applications: create, read, update, and delete. Alright, whether you are trying to learn how APIs interact with applications or controllers, need to test code and outcomes, or want to become a full-time developer, one of the most important pieces of interacting with any software using APIs is testing. Testing code helps ensure that developers are accomplishing the outcome that was intended when executing the code. This video covers some tools and resources related to using APIs and test functions. This information will help you know about the development skills in order to become a more efficient network engineer with coding skills. Alright, now let me to introduce the Postman, one of the common API tools that we can use it. Earlier in this video, we mentioned that we can interact with the software controller using RESTful APIs. It also discussed being able to test code to see if the desired outcome are accomplished when executing the code. Keep in mind that APIs are software interfaces into an application or a controller. Many APIs require authentication. This means that such an API is considered just like any other devices to which a user needs to authenticate to gain access to utilize the APIs. A developer who is authenticated has access to making change using the API, which can impact that application. This means if a REST API call is used to delete data, that data will be removed from the application or controller, just as if a user logged into the device via the CLI and deleted it. It is best practice to use a test lab or the Cisco DevNet sandbox while learning or practicing any of these concepts to avoid accidental impact to a production or lab environment. Postman is an application that makes it possible to interact with APIs using a console-based approach. Postman allows for the use of various data types and formats to interact with the REST-based APIs. Here we can see the main Postman application dashboard, and don't forget, according to the version that you use, maybe you see a little different dashboard here. This is the Postman dashboard. We have for example some menus and also some options that we can use them for many features related to the application programming interfaces. You can create the workplace that you want. For example, let me to go to my workplace. Here we have many options. For example, we have collections, APIs, environments, and some other features. For example, here you can see the history tab. The history tab shows a list of all the recent API calls made using the Postman. Users have the option to clear their entire history at any time if they want to remove the complete list of the API calls that have been made. This is done by clicking the Clear All link at the top of the collection window. As you can see here, we can use Clear All. Users also have the ability to remove individual API calls from the history list by simply hovering the mouse over an API call and clicking the trash can icon in the sub-menu that pops up. Let me to show you. For example, we can hover to the API call that we have before, and here we have some options. Look at here, delete a request. Also, API calls can be stored in groups called collections. Okay, here we have the collections, and that are specific to a structure that fits the user's need. Collections can follow any naming conventions and appear as a folder hierarchy, as you can see. Okay, this is a folder hierarchy. For example, it is possible to have a collection called DNA Center, or for example Cisco SD-WAN Always On, or other things, to store all the Cisco DNA Center API calls. Saving API calls to a collection helps during testing phases, as the API calls can easily be found and stored. It is also possible to select a collection to be a favorite by clicking the star icon to the right of the collection. For example, name. As you can see here, we have the star icon. You can click it here, and actually it means that now this is the favorite list that we have. Also, tabs provide another very convenient way to work with various API call. Now here we have various API call and we can use them. Okay, it means that each tab can have its own API call and parameters that are completely independent of any other tab. For example, a user can have one tab open with API calls interacting with the Cisco DNA Center controller, and another tab open that is interacting with a completely different platform such as the Cisco Nexus switch. Each tab has its own URL bar to be able to use a specific API. Remember that an API call using REST is very much like an HTTP transaction, and each API call in a RESTful API maps to an individual URL for a particular function. This means every configuration change or poll to retrieve data a user makes in a REST API has a unique URL, whether it is a get, post, put, patch, or delete function. Look at here, as you can see, for example, in this tab, we have the get function, and this is the URL. Also, if you want, you can change the verb to post, to put, to patch, to delete, to copy, to head, and other, for example, verbs. And here, as you can see, we have different tabs. In each tab, we have one verb or one action, okay, and also one URL. All right, now let me to explain a little about the data formats XML and JSON. You know that we learned about them in the previous video. Here we are reviewing some of the topics. Now that the Postman dashboard has been shown, it's time to discuss two of the most common data formats that are used with APIs. The first one is called Extensible Markup Language, or XML. This format may look familiar as it's the same format that is commonly used when constructing web services. XML is a tag-based language, and a tag must begin with for example, a greater than or lower than symbol, and end with a for example, greater than symbol. This is the lower than, this is the greater than. Okay, this is a tag. For example, a start tag named interface would be represented as the for example, lower than, then the interface, again the greater than. Let me to write here, this is a tag for interface, and then again the greater than symbol. Okay, and for example, you know that another example XML rule is that a section that is started must also be ended. So if a start tag is called the interface, okay, the section needs to be closed by using an accompanying end tag. The end tag must be the same as the string of the start tag, preceded by a slash. Okay, I will show you. Look at here. For example, here we have a tag, a name, and then look at here, a slash, again name. It is so easy. Inside the start tag and end tag, you can use different code and parameters. This example shows a snippet of XML output with both start and end tags, as well as some configuration parameters. As you can see, for example, we can gather information about them. Note that each section of this example has a start tag and an end tag. The data is structured so that it contains a section called users, and within the section are 4 individual users: root, JSON, Jamie, and Luke. Let me to show you. This is the start tag, and this is the end tag. Okay, again here we have the start tag. Let me to show you, and after that we have the for example, end tag, and then again a start tag. Let me to show you. This is a start tag, and this is the end tag. After that we have the next start tag. Let me to show you, and after that we have the end tag. This is obvious, and here also we have the next start tag. Okay, and finally the end tag. Don't forget, in each line also we have a tag. I'm going to show you a start tag and end tag. Here we have a start tag and end tag. Again here we have a start tag and end tag, and finally here 8 and 9. Okay, this is the start tag and end tag structure in the XML code snippet. Before and after each username is the start tag user and the end tag slash user. The output also contains the start tag name and the end tag slash name. These tags are used for each user names. Okay, if it is necessary to create another section to add another user, you can simply follow the same logic as used in the previous example and build up more XML code. Remember that one of the key features of XML is that it is readable by both humans and applications. Indentation of XML sections is part of what makes it so readable. For instance, if indentation isn't used, it is harder to read and follow the sections in XML output. Although indentation is not required, it is certainly a recommended best practice from a legibility perspective. This example shows an XML snippet listing available interfaces on a device. In this case, the XML code snippet has no indentation. So you can see how much less readable and this snippet is than the one in the previous example. As you can see, here we don't have any indentation. The second data format that is important to cover is called JavaScript Object Notation, or JSON, as you learned before. Although JSON has not been around as long as XML, it is taking the industry by storm, and some say that it will soon replace XML. The reason this data format is gaining popularity is that it can be argued that JSON is much easier to work with than XML. It is simple to read and create, and the way the data is structured is much cleaner. JSON stores all its information in key value pairs. As with XML, JSON is easier to read if the data is indented. However, even without indentation, JSON is extremely easy to read. As the name suggests, JSON uses object for its format. Each JSON object starts with a curly bracket or opening curly bracket and ends with a closing curly bracket. These are commonly referred to as curly braces. Okay, this example shows how JSON can be used to represent the same username example shown, for example, in previous scenario. You can see that it has 4 separate key value pair, one for each username. As you can see, opening curly bracket, double quotes, user, colon, and then double quotes root. This is the username, this is the key, this is the value. Also after that we have a comma, again key, comma, a colon, value, comma, key, colon, value, comma, and after that again key, colon, and value. Here we don't have comma, and finally we have the closing curly brackets. In this JSON code snippet, you can see that first key is user and the value for that key is a unique username root. Now that the XML and JSON data formats have been explained, it is important to circle back to actually using the REST APIs and the associated responses and outcomes of doing so. First, we need to look at the HTTP response status code. Most internet users have experienced the 404 not found error when navigating to a website. However, many users don't know what this error actually means. This table lists the most common HTTP status codes as well as the reasons user may receive each one. For example, about the HTTP status code 200, the result is okay. Common reason for response code is using GET or POST to exchange data with an API. About the code 201, this is the result of creating resources by using a REST API call. 400 bad request failed due to client-side issue. 401 unauthorized client not authenticated to access site or API call. 402 forbidden access not granted based on supplied credential. And 404 not found page at HTTP URL location does not exist or is hidden. Also here you can see the global status of HTTP codes. For example, 1xx, this is informational code, and then 2xx like 200 or 201, this is the success message. Redirection 3xx, and also client error 4xx and server error 5xx. For example, for 400, 401, 403, 404, all of them related to the client errors. Alright, now let me to explain about the Cisco DNA Center APIs. You know that the Cisco DNA Center controller expects all incoming data from the REST API to be in JSON format. It is also important to note that the HTTP POST function is used to send the credential to the Cisco DNA Center controller. Cisco DNA Center uses basic authentication to pass a username and password to the Cisco DNA Center token API to authenticate users. This API is used to authenticate a user to the Cisco DNA Center controller to make additional API calls. Just as users do when logging into device via the CLI, if secured properly, they should be prompted for login credential. The same method applies to using an API to authenticate to software. The key steps necessary to successfully set up the API call in Postman are as follows. Actually, here now we are trying to establish the API call to the Cisco DNA Center APIs. Okay, let me to show you here. We have the Postman. Okay, and as you can see, now we don't have any available tab. Let me to open a tab, and then here now we can start the, for example, API call. Here, as you can see, we have different functions, okay, or different verbs of the HTTP, and here you can input the for example, or you can request the URL. Here I'm going to show you what should we do. Maybe in some cases our try will unsuccessful, but if you want, you can try it, or in some cases you can search about the new URLs that we have for some sandbox or some other things. First, in the URL bar, okay, you can enter this address, okay, and after that, here, for example, this is our address, https://sandbox DNAC or the dnacenter.cisco.com/API/system/version1 authentication, and then a token. Okay, this is the first step. And after that, select the HTTP post. Okay, this is the HTTP post. As I mentioned before, it is also important to note that the HTTP post function is used to send the credential to the Cisco DNA Center controller. Because of that, here we are using the HTTP post. After that, under the authorization tab, here under the authorization tab, ensure that the type of authorization is set to basic authentication. Look at here in the authorization. Here we should use the basic authentication. And after that, here when you selected the basic authentication, you should enter the username and a password. Let me to show you. This is the username, DevNet user, okay, and about the password you can use Cisco with this format 123 exclamation. Username and password, this is our credential. After that, you should select the headers tab. In the headers tab, we should add a key and also a value. Look at here in the key, let me to type the content type. Actually, here we configure which type of information we have. Content type, this is the content type, and here you should use application JSON. Don't worry about the detail. Detail is not important now for us. Only we are trying to know what is happening in one example, in one instance of the tools for API call. Okay, look at here. We configured the headers. Okay, and now here we can click on the send. Let me to review. The HTTP post is the verb, and this is the URL. And in authorization, we selected basic authentication, and this is our username and password. And in the headers, I selected content type and application. Content type here for the value, we use application with JSON format. That's it. Okay, now click the send button to pass the credential to the Cisco DNA Center controller via the token API. Look at here, send. We need to wait some second. Okay, as you can see here, now we have the token. You need a token for any future API calls to the Cisco DNA Center controller. When you are successfully authenticated to the Cisco DNA Center controller, you receive a token that contains a string that looks similar to the following. Okay, this is our token. Okay, think of it as a hash that is generated from the supplied login credential. The token changes every time an authentication is made to the Cisco DNA Center controller. It is important to remember that when you are authenticated, the token you receive is usable only for the current authenticated session to the controller. If another user authenticates via the token API, he or she will receive a unique token to be able to utilize the API based on his or her login credential. Okay, this figure shows the response from the Cisco DNA Center after you issue the post operation on the token API. Okay, now you can see in the top right of the screen, okay, here, okay, in the top right of the screen, okay, that the receive HTTP status code from the Cisco DNA Center controller is 200 or okay. Look at here, 200. Okay, based on the list that we saw before, you can tell that the HTTP status code 200 means that the API completed successfully. In addition, you can see how long it took to process the HTTP post request, for example, 1911 millisecond. Okay, now we can take a look at some of the other available API calls. The first API call that is covered in this video is the network device API, which allows users to retrieve a list of devices that are currently in inventory that are being managed by Cisco DNA Center controller. You need to prepare Postman to use the token that was generated when you successfully authenticate to the controller by following steps. Okay, first, step 1, copy the token you received earlier and click a new tab in the Postman. Actually, now we should copy it. Okay, let me to copy it, and after that here we should open a new tab. This is a new tab. In the URL bar, enter the address or the URL. Here I'm going to use one URL, but maybe in some cases you need to change the URL to other URL. Let me to show you. This is our URL, okay, and here I'm going to copy it here in the URL. Look at here, https://sandbox.nac.cisco.com/API/version1/network device. Okay, this is the target or the network device API. Select the HTTP GET operation from the drop-down box and select the headers tab and enter content type as the key. Again, here in the headers, the key is the content type. Let me to type it here, and you know that we should use application JSON. This is the content type, and after that add another key and enter X authentication token. Okay, here let me to add another key. This is the X authentication token, and for about the values we should paste the token that we received previously. From here we can copy the token. Let me to add it here in the keys. Okay, and after that, don't forget you should copy from here. Let me to copy it from here to the end, okay, to here. Or if you want, you can use another format. This is pretty format, this is raw format, this is preview format, this is visualize format. Okay, let me to use raw, and after that here I'm going to copy the key. Okay, and this is the token, copy, and then we can paste it here. Let me to paste it here. Okay, and if you want, you can remove it first and then again add it. Let me to remove this. Okay, and after that again and then paste it again here. Now it's okay, and after that paste the token in the value, click send to pass the token to the Cisco DNA Center controller and perform an HTTP GET to retrieve a device inventory list using the network device API. If you click send, you will see a message. Look at here, now we received the device inventory list with the from the network device API. Don't forget, the token you receive will be different from the one that here we can see. Remember that the token is unique to each authenticated user. Based on the response, let me to show you again, the status is 200 is okay. Based on the response received from the Cisco DNA Center controller, you can see that the HTTP status code 200 okay. And you can also see that the device inventory was received. Let me to show you. Here we can see the device inventory, like the description, a device support level, software type, software version, and some other information about the device. Actually, this example shows a list of devices in the inventory that were pulled using the network device API. Okay, and after that, by now you should see how powerful APIs can be. Within a few moments, users are able to gather a tremendous amount of information about the device currently being managed by the Cisco DNA Center controller. In the time it takes someone to log into a device using the CLI and issue all the relevant show command to gather data, an API call can be used to gather that data for the entire network. APIs gives network engineers time to do other things. As you can see now here, we have information from many devices. For example, Cisco controller wireless version, and after that here we have other device. The next device is the, for example, Catalyst layer 3 switch software and some other devices. Here we have multiple devices in the inventory list. And when using APIs, it is common to manipulate data by using filters and offsets. Say that a user wants to leverage the network device API to gather information on only the second device in the inventory, or this is where the API documentation becomes so valuable. Most APIs have documentation that explains what they can be used to accomplish. In Postman, it is possible to modify the network device API URL and add limit 1. Let me to show you. Here, I'm going to add limit 1 and then send to the end of the URI to show only a single device in the inventory. Now here we have only the single device in the inventory, as you can see. And also it is also possible to add the offset 2 command. Let me to add it here. I'm going to add the offset 2 and again send it to the end of the URL to state that only the second device in the inventory should be shown. As you can see here, we receive error message, but it is related to the for example, first we should use the limit 1 and then offset limit 2. Look at here, offset 2, that's it, and then send it again. Now here we have the second device, as you can see. And after that, these query parameters are part of the API and can be invoked using a client-like Postman as well. Although it may sound confusing, the limit keyword simply states that a user only wants to retrieve one record from the inventory, and the offset command states that the user wants to that one record to be the second record in the inventory. This figure shows how to adjust the network device API URL in Postman to show information on only the second device in the inventory. You can see from the response that the second device is consistent with the output that was shown in the initial network device API call. This device is a Cisco Catalyst layer 3 switch, okay, and with this specific information. Alright, now let me to explain about the Cisco vManage APIs. This section discusses the various APIs available in the Cisco SD-WAN, specifically the vManage controller. This section provides some examples of how to interact with APIs programmatically by using Postman. Leveraging Cisco SD-WAN API is a bit different from using the Cisco DNA Center APIs, but the two processes are quite similar. As when using a Cisco DNA Center API with a Cisco SD-WAN API, you need to provide login credential to the API in order to be able to utilize the API call. The steps for connecting to APIs are different for Cisco SD-WAN than for Cisco DNA Center. Detailed steps for setting up the Postman environment for Cisco SD-WAN are available at this address, https://developer.cisco.com/sdwan, and the Cisco DNA Center Postman environment setups steps are available at the https://developer.cisco.com/learning/tracks/DNA Center Programmability. Okay, to set up a Postman environment, you can simply download app steps into Postman from DevNet by going to https://developer.cisco.com/sdwan. By doing so, you can quickly set up an environment that contains all the necessary authentication, detail, and practice with the APIs without having to spend much more time getting familiar with the detail of Postman. Okay, here as you can see, let me to show you, I configured the requirement for the SD-WAN, the sandbox of SD-WAN, and as you can see now here we have the returned information with the status code of the, okay, you know that in SD-WAN we have multiple components, vManage, vEdge, and also vBond, and also vSmart, and some other detail are available here. Actually, when the Postman environment is all set up and you click the send button, the credentials are passed to vManage using the authentication API, and the response you receive delivers something called a Java session ID, which is displayed as JSession ID. This is similar to the Cisco DNA Center token you worked with earlier in this video. This session ID is passed to vManage for all future API calls. For this user, an HTTPS status code 200 OK indicate a successful post to vManage with the proper credential. Now let's take at another API call that collects an inventory of Fabric devices within the Cisco vManage. Using the HTTP GET operation, this API collects the requested information and displayed it in the Postman. In this figure, you can see a lot from Cisco vManage response. You can see the URL for this API in the URL bar, and you can also see the HTTP GET request. You can also see that the response is in JSON format, okay, which makes the data easy to read and consume. If you scroll down in the response, you can see a list of devices under the data key, okay, and here we have the list of devices, and after that these keys received from the API call. This list contains a series of information about each Fabric device within the Cisco vManage. Some of the information that you will see is the device ID, system IP, host name, reachability, status, device type, and also the site ID. Let me to show you some of them. For example, here, as you can see, we have many information related to the devices. For example, vManage and other devices. Okay, let me to show you here. For example, device ID, system IP, host name, reachability, status, personality, device type, time zone, and some other things. Also, for the next device, for this device, we have other information. If you learn about the Cisco SD-WAN, you can understand each of these parameters and their functionality. As you can see, a single API call has the power to gather significant amount of information. How the data is used is up to the person making the API calls and collecting the data. All the tools, processes, and APIs can be leveraged to provide tremendous value to the business, from visibility into the environment to building relevant use cases to be consumed by the business or its customers. Alright, now let me to explain about the data models and supporting protocols. This section provides a high-level overview of some of the most common data models and tools and how they are leveraged in a programmatic approach, about the yet another next generation or YANG modeling language, about the network configuration protocol or NETCONF, and finally RESTCONF. Let me to start with the yet another next generation or YANG modeling language. SNMP is widely used for fault handling and monitoring. However, it is not often used for configuration change. CLI scripting is used more often than other tools. YANG data models are an alternative to SNMP management information bases and are becoming the standard for data definition language. YANG, which is defined in RFC 6020, uses data models. Data models are used to describe whatever can be configured on a device, everything that can be monitored on a device, and all the administrative actions that can be executed on a device, such as resetting counters or rebooting the device. This includes all the notification that the device is capable of generating. All these variables can be represented within a YANG model. Data models are very powerful in that they create a uniform way to describe data, which can be beneficial across vendors' platform. Data models allow network operators to configure, monitor, and interact with network devices, for example, across the entire enterprise environment. YANG model use a tree structure. Within that structure, the models are similar in format to XML and are constructed in modules. These modules are hierarchical in nature and contain all the different data and types that make up a YANG device model. Yang models make a clear distinction between configuration data and state information. The tree structure represents how to reach a specific element of the model, and the element can be either configurable or not configurable. Every element has a defined type. For example, an interface can be configured to be on or off. However, the operational interface state cannot be changed. For example, if the options are only up or down, it is either up or down, and nothing else is possible. This example shows a simple Yang model taken from the RFC 6020. The output in this example can be read as follows. There is food. Of that food, there is a choice of snacks. The snack choices are pretzels and popcorn. If it is late at night, the snack choices are two different types of chocolate. A choice must be made to have milk chocolate or dark chocolate. And if the consumer is in a hurry and does not want to wait, the consumer can have the first available chocolate, whether it is milk chocolate or dark chocolate. The next example shows a more network-oriented example that uses the same structure. The Yang model in this example can be read as follows. There is a list of interfaces. Of the available interfaces, there is a specific interface that has 3 configurable speeds. Those speeds are 10 megabit per second, 100 megabit per second, and auto, as listed in the leaf named speed. The leaf named observed speed cannot be configured due to the config false command. This is because as the leaf is named, the speeds in this leaf are what was auto-detected or observed. Hence, it is not a configurable leaf. This is because it represents the auto-detected value on the interface, not a configurable value. The next protocol is the Network Configuration Protocol, or NETCONF. NETCONF, defined in RFC 4741 and RFC 6241, is an IETF standard protocol that uses the Yang data model to communicate with the various devices on the network. NETCONF runs over SSH, TLS, and, although not common, a simple object access protocol, or SOAP. Some of the key differences between the SNMP and NETCONF are listed in this table. One of the most important differences is that SNMP can't distinguish between configuration data and operational data, but NETCONF can. Another key difference is that NETCONF uses paths to describe resources, whereas SNMP uses object identifier, or OIDs. A NETCONF path can be similar to interface ETH0, which is much more descriptive than what you would expect from the SNMP. Let me to review this table about the feature. Here we have the resources. In SNMP, the resources are OID, and in NETCONF we call it paths. Data model in SNMP defined in MIBS, or management information base. In NETCONF, Yang core model. Data modeling language, SNMP SMI. In NETCONF it is Yang. Management operation, SNMP, and NETCONF. Encoding, in SNMP we use BER, and in NETCONF we use XML and also JSON. And transport stack is in SNMP is UDP, and in NETCONF is SSH and TCP. Don't worry about some of the detail, they are beyond the scope of this video. The following is a list of some of the common use cases for NETCONF: collecting the status of specific fields, changing the configuration of specific fields, and taking administrative actions, sending event notification, backing up and restoring configuration, and testing configuration before finalizing the transaction. Actually, transactions are all or nothing. There is no order of operations or sequencing within a transaction. This means there is no part of the configuration that is done first. The configuration is deployed all the same time. Transactions are processed in the same order every time on every device, and transactions when deployed run in parallel state and do not have any impact on each other. Parallel transactions touching different areas of the configuration on a device do not override or interfere with each other. They also do not impact each other if if the same transaction is run against multiple devices. This example provides an example of a NETCONF element from RFC 4741. This NETCONF output can be read as follows. There is an XML list of users named users. In that list, there are individual users named Dave, Rafael, and Dirk. Okay, as you can see here, an alternative way of looking at this type of NETCONF output is to simply look at it as though it were a shopping list. This example provide an example of the shopping list concept. It can be read as follows. There is a group called beverages, and of this beverage there are soft drinks and tea. The available soft drinks are cola and root beer. Of the available tea, there is a sweetened or unsweetened. This figure illustrates how NETCONF uses Yang data models to interact with network devices and then talk back to management application. The dotted line shows the devices talking back directly to the management applications, and the solid line illustrates the NETCONF protocol talking between the management application and the devices. NETCONF exchange information called capabilities when the TCP connection has been made. Capabilities tell the client what the device it's connected to can do. Okay. Furthermore, other information can be gathered by using the common NETCONF operations. In this table, we can see the common NETCONF operation, as you can see here, and information and configuration are stored in data stores. Data stores can be manipulated by using the NETCONF operation that you can see here. NETCONF uses remote procedure call or RPC messages in XML format to send the information between hosts. As you can see about the NETCONF operation, we have get config, edit config, copy config, and delete config. With get, we can request running configuration and state information from the device. With get config, we can request some or all of the configuration from a data store. With edit config, we can edit a configuration data store by using CRUD operations. With copy config, copies the configuration to another data store. And with delete config, we can delete the configuration. Now that we have looked at the basics of NETCONF and XML, let's examine some actual example of a NETCONF RPC message. This example shows an example of an OSPF NETCONF RPC message that provides the OSPF routing configuration of an iOS XE devices. The same OSPF router configuration that would be seen in the command line interface of a Cisco router can be seen using NETCONF. The data is just structured in XML format rather than what users are accustomed to seeing in the CLI. It is easy to read the output in this example because of how legible XML is. This example saved the configuration of a Cisco network device by leveraging NETCONF, and here we can easily understand that this configuration for save the config of the Cisco network device by using the NETCONF. Don't worry about the detail. Detail is beyond the scope of this video. Now we are trying to understand the role of each of these features in the, for example, network programming. Actually, now we know that NETCONF is a protocol that we can use it for sending our commands to the devices and also receive some information from the devices. This is like the SNMP, but you know that here we have some differences between the SNMP and NETCONF. Now let me to explain a little about the RESTCONF. RESTCONF defined in RFC 8040 is used to programmatically interface with data defined in Yang model while also using the data store concept defined in NETCONF. There is a common misconception that RESTCONF is meant to replace NETCONF, but this is not the case. Both are very common methods used for programmability and data manipulation. If in fact RESTCONF uses the same Yang model as NETCONF and Cisco iOS XE. The goal of RESTCONF is to provide a RESTful API experience while still leveraging the device abstraction capabilities provided by NETCONF. RESTCONF support the following HTTP methods and CRUD operations: get, post, put, delete, and options. The RESTCONF request and response can use either JSON or XML structure data formats. This example, as you can see, shows a brief example of a RESTCONF GET request on a Cisco router to retrieve the logging severity level that is configured. This example uses JSON instead of XML. Notice that HTTP status 200, which indicate that the request was successful. As you can see here, we have the status code of 200, and this is the RESTCONF GET request. In this figure, you can see the NETCONF, RESTCONF, and another protocol gRPC. And with the YANG data model, okay, we have a communication with the, for example, device. Here we have some other detail also. But as you can see, NETCONF and RESTCONF are two methods that we can communicate with the devices. Both of them are using the YANG data models. Alright, now let me to explain a little about the Cisco DevNet. Network operators who are looking to enhance or increase their skills with APIs, coding, Python, or even controller concept can find a wealth of help at DevNet. At DevNet, it is easy to find learning labs and content to help solidify current knowledge in networking programmability. Whether you are just getting started or are a seasoned programming professional, DevNet is the place to be. This section provides a high-level overview of DevNet, including the different sections of DevNet and some of the labs and content that are available. This figure, okay, can show us the DevNet main page at the address http://developer.cisco.com. Here, as you can see, across the top of the main page are a few menus options. Here, as you can see, we have Discover, we have Technologies, a Community, Support, Event, and also New Enhancement. Let me to explain a little about each of them. For example, about the Discover, okay? In Discover, actually the Discover page is where you can navigate the different offerings that DevNet has available. Under this tab are subsections for guided learning tracks, which guide you through various technologies and the associated API labs. Some of the labs you interact with are programming the Cisco Digital Network Architecture, DNA, HCI programmability, getting started with Cisco WebEx Teams APIs, and introduction to network. And also, when you choose a learning lab and start a module, the website tracks all your progress so you can go away and come back and continue where you left off. This is helpful for continuing your education over the course of multiple days or weeks. The next menu is the Technologies. Actually, the Technologies page allows you to pick relevant content based on the technology you want to study and dive directly into the associated labs and training for that technology. Here we can see different technology, IoT, okay, or cloud, or networking, data center, collaboration, security, and in each of them we have different features and different, for example, lands. Actually, the technology page allows you to pick relevant content based on the technology, okay? And you know that here we have other options. For example, community. Perhaps one of the most important section of DevNet is the community page. This is where users have access to many different people at various stages of learning. Okay, DevNet, for example, can help us to find the people with various stages of learning journey. The community page puts the latest events and news at your fingertips. This is also the place to read blogs, sign up for developer forums, and follow DevNet or all major social media platforms. This is a safe zone for asking questions, simple or complex. The DevNet community page is the place to start for all things Cisco and network programmability. And here, as you can see, we have the support page. In the support section of DevNet is where users can post questions and get answers from some of the best in the industry. Technology-focused professionals are available to answer questions both from technical and theoretical perspective. You can ask questions about specific labs or the, for example, technology, for example, Python or Yang models. You can also open a case with the DevNet support team, and your question will be tracked and answered within a minimal amount of time. This is a great place to ask one-to-one question of the support team, as well as tap into expertise of support engineers. In the event page, as you can see here in the event page, the DevNet event page provides a list of all events that have happened in the past and that will be happening in the future. This is where a user can find the upcoming DevNet, for example, Express events, as well as a conference where DevNet will be presenting. Bookmark this page if you plan on attending any live events. Alright, now let me to explain a little about the GitHub. One of the most efficient and commonly adopted ways of using version control is by using GitHub. GitHub is a hosted web-based repository for code. It has capabilities for bug tracking and task management as well. Using GitHub is one of the easiest ways to track changes in your files, collaborate with other developers, and share code with the online community. It is a great place to look for code to get started on programmability. Oftentimes, other engineers or developers are trying to accomplish similar tasks and have already created and tested the code necessary to do so. One of the most powerful features of using GitHub is the ability to rate and provide feedback on other developers' code. Peer review is encouraged in the coding community. This figure shows the main GitHub web page that appears after you log in. GitHub provides a guide that steps through how to create a repository, start a branch, add comments, and open a pull request. Okay, and you can also just start a GitHub project when you are more familiar with the GitHub tool and its associated processes. Projects are repositories that contain code file, and GitHub provides a single pane to create, edit, and also share code files. Okay, GitHub also gives a great summary of commit logs. So when you have or you save a change in one of your files or create a new file, GitHub shows detail about it on the main repository page. Alright, in this section I'm going to review a little about the Python components and scripts. Python has a long shot become one of the most common programming language in terms of network programmability. Learning to use programming language can be daunting. Python is one of the easier language to get started with and interpret. Although this section does not cover how to create or write complex program or a script in Python, it does teach some of the fundamental skills necessary to be able to interpret Python scripts. When you understand the basics of interpreting what a Python script is designed to do, it will be easier to understand and leverage other scripts that are available. GitHub has become amazing Python scripts available for download that come with very detailed instructions and documentation. Everything covered in this section is taken from publicly available GitHub scripts. This section leverages the new knowledge you have gained in this video about APIs, HTTP operation, DevNet, and GitHub. Okay, actually, this example shows a Python script that sets up the environment to log into the Cisco DNA Center sandbox. This script uses the same credential used with the token API earlier in this video, and you know that we implemented the Cisco DNA Center API connectivity. As you can see, this Python script starts with 3 quotation marks. These 3 quotation marks begin and end a multiple line string. A string is simply one of more alphanumeric characters. A string can comprise many numbers or letters depending on the Python version in use. In the case of this script, the creator used a multiple line string to put additional overall comment into the script. This is not mandatory, but you can see that comments are helpful. Okay, the sign character indicate a comment in the Python script file, such comments usually describes the intent of an action within the code. Comments often appear right above the action they describe. Some scripts have a comment for each action, and some are not documented very well, if at all. The comments in this script indicate that there are 3 available options for selecting the lab environment to use. As you can see here, we have sandbox, we have express, and also custom. Sandbox, the line in this Python script that says environment in use equal to sandbox corresponds to the selection of the sandbox type of lab environment available through DevNet. In this instance, sandbox refers to the always on and reserved sandboxes that can be accessed through http://developer.cisco.com. Also, about the Express, this is the backend that is used for the DevNet Express events that are held globally at various locations and Cisco office locations, as mentioned earlier in this video. And about the custom, this is used in the event that there is already a Cisco DNA Center installed either in a lab or another facility, and it needs to be accessed using this script. Okay. Here we are using the sandbox lab environment for all explanations. As you can see in the Python script, a few variables are used to target the DevNet Cisco DNA Center sandbox specifically. For example, about the variable of host, the value includes sandboxnac.cisco.com, and it is actually the Cisco DNA Center sandbox URL. About the port is 443 TCP port to access URL securely HTTPS. Username is DevNet user. This is a username to log into Cisco DNA Center sandbox via API or GUI. And password is Cisco123 exclamation, password to log into the Cisco DNA Center sandbox via again API or GUI. The variables shown here should look familiar as they are in the JSON data format that was discussed earlier in this video. Remember that JSON uses key value pair and is extremely easy to read and interpret. You can see the key value pair username DevNet user, okay, or password Cisco123. The structure used to hold all the key value pairs in this script is called a dictionary, as I mentioned, as I explained in the previous video. In this particular Python script, the dictionary is named DNAC, okay, or DNA Center. The dictionary named DNAC contains multiple key value pairs, and it starts and ends with curly braces. Dictionaries can be written in multiple different ways. As you can see here, we have dictionary used in the script of Python script actually, and here we have a single line example of dictionary used in the Python script. And here it can show a multiple line dictionary, okay, at the top figure that is easily readable, but this example, the bottom figure, shows the same dictionary written at a single line. Also, notice that the line environment in use sandbox is used in this script. Following that line in the script is a line that states if environment in use equal to sandbox. This is called the condition, okay, as you can see. And a logical if question is asked, and depending on the answer, an action happens. In this example, the developer called out to use the sandbox option with the line of code environment in use equals sandbox, and then use a condition to say that if the environment in use is sandbox, call a dictionary named DNAC to provide the sandbox details that are listed in key value pairs. And because of that, after that, we can use this key value pair for connecting to the, for example, a sandbox. Now let's look at the script that showcases much of the API information and also builds on all the basic Python information that has just been provided. This example shows a Python script called get_DNAC_devices PY. It might seem like there is a lot going on in the getDNAC device.py script. However, many of the details have already been explained. This section ties together all the components discussed previously and expands on how they work together by breaking the script into 5 sections with explanations. The first section of code tells the Python interpreter what modules this particular script will use. Think of a module as a collection of actions and instructions. Let me to explain a little about each of these lines. For example, here we have this line. This specifies which version of Python will be used. Here we have the version 3, for example. After that, here in the next line from env lab import DNAC, this calls DNAC the dictionary from the env underline lab.py script covered previously. After that, here we have the import JSON. Imports JSON module so Python can understand the data format that contain key value pair. After that, here we have import request module which handles HTTP header and form data. After that, we have import the URL library tree. Okay, this imports URL lib3 module which is an HTTP client. After that, here we have the next line from request and this imports HTTP basic authentication method from the request.authentication module for authentication to the Cisco DNA center. After that, in the next line from pretty table import pretty table, this imports pretty table component from pretty table module to structure return data from Cisco DNA center in table format. Module help Python understand what is capable for example, if a developer tried to do an HTTP GET request without having the request module imported, it would be difficult for Python to understand how to interpret the HTTP call. Although there are other ways of doing HTTP calls from Python, the request modules greatly simplify this process. Okay, now let me to continue. The next, for example, line is the DNAC device pretty table, okay, and includes some parameters. Actually puts return data from Cisco DNA Center Network Device API call into easily readable table with column names, host name, platform ID, software type, software version, and also uptime. Okay, and here we have the next line, URL lib3 and other functions. This silences the insecure warning due to the SSL certificate. After that, here we have the next line, the for example headers. It sends a specific HTTP headers to Cisco DNA Center when issuing HTTP GET to the network device API. Functions are blocks of codes that are built to perform specific actions. Functions are very structured in nature and can often be reused later on within a Python script. Some functions are built into Python and do not have to be created. A great example of this is the print function, which can be used to print data to a terminal screen. You can see the print function at the end of the getDNAC device.py script, as you can see here. Okay, and we can say, recalling from earlier functions, that in order to execute any API calls to Cisco DNA Center, you must be authenticated using the token API. This example shows the use of the token API within a Python script. Recall that you saw this API used with Postman earlier in this video. Okay, look at here. Here we have the defined DNAC login, and here we have the features that we need for the authentication. This function does an HTTP post of the username DevNet user and the password of Cisco123 exclamation to the token API located at https://sandbox.nac. For example, cisco.com/API/system/version1 authentication token, and uses the values built in the JSON key value pair from the environment lab py. The JSON response from the API called is stored as the token that will be used for future API calls for this authenticated user. And in this section, actually this section of the script ties the token API to the network device API call to retrieve the information from Cisco DNA Center. The line that says header X authentication, for example, token equal token is mapping the JSON response from the previous part, which is the token, into the header called X authentication token. In addition, the URL for the API has changed to network device, and the response is sending a request .get to that URL. This is exactly the same example used with Postman earlier in this video. The final section of get underscore DNA underscore devices.py shows code that ties the DNAC dictionary that is in the environment that underscore lab.py script to the DNAC underscore login function. In addition, the print function takes the response received from the response.get that was sent to the network device API and puts it into the table format that was specified earlier in the script with the name DNAC underline devices. The Python script example in this video makes it easy to see the power and easy to use nature of Python. You practice with the examples in this video to increase your experience with Python and API structure. The tools mentioned in this video, including Postman and Python, are readily available on the internet for free. These tools, examples, and much more can be studied in depth at http://developer.cisco.com. The tools covered in this video are available online and are very useful in terms of building skills and expertise. Go to DevNet to practice with any of the technologies covered in this video. It is often said of programmability that you can start small, but you should just start. A great way to practice is by using a sandbox environment and just building code and running it to see what can be accomplished. You are only limited by your imagination and coding skills. Remember to have fun and keep in mind that programmability is a journey, not a destination. Separating your learning into small, manageable chunks will make it easier to get better with practice and time.